Good evening, one and all. I hope and pray all our viewers are safe in this pandemic situations. Learning is a new way to grow our life. In Dr. D.Y. Patil Group, we believe in continuous learning, so we have introduced these knowledge sharing webinars. I am Ms. Jyoti Joshi, Assistant Professor in Dr. D.Y. Patil Group's deemed to be University, Ramrao Adik Institute of Technology, popularly called as RAIT, would like to welcome you all to this webinar series conducted by Information Technology Department in association with ACM Student Chapter. Webinar series are inspired by motivation given to us by Dr. D.Y. Patil Sir, founder of Dr. D.Y. Patil Group, and Dr. Vijay Patil Sir, Chancellor of D.Y. Patil University. RAIT firmly believes in new form of engineering education that lays equal stress on academics, leadership building, and extracurricular skills with industry exposure. This has been a major contribution to the success of RAIT students. RAIT has highest number of campus placements in Mumbai region. RAIT is one of the most reputed institutions for engineering courses. RAIT has ranked in first 100 universities by NIRF and is continuously accredited by NAC. When you have enthusiasm and passion, you end up figuring out how to excel. RAIT College has culture of continuous learning. Faculties and students are always passionate about exploring new advances in the technologies by participating in workshops, hackathons, tech talks, projects, and many such events. Today we have one such enthusiastic speaker, Mr. Vivek Somani, with us on the webinar for the topic Introduction to AWS. The webinar will cover the major topics such as what is cloud, what does AWS offers, the general architecture of AWS and security in AWS. Before I hand over session to our speaker for the webinar, I would like to warmly welcome our speaker, Mr. Vivek Somani, for the webinar. And before I hand over session to him, I would like to give a brief introduction of our speaker. The speaker of the webinar, Mr. Vivek Somani, he is currently working as DevOps security engineer with Applied Cloud Computing. We are proud to say that Vivek Somani is our alumna, having completed his bachelor's degree in IT engineering from RAIT. He is skilled in various technologies such as Python, RESTful API integration, Django frameworks, Azure Machine Learning Studio, Azure Cognitive Series, Azure Q&A Maker, AI, MySQL, DB, Google Firebase, real-time database, and AWS Basics. He has various certifications in his credit, such as Microsoft Certified Azure Fundamentals AZ900, Azure Ninja Cat, and Oracle's Java IoT Developer Workforce, and Certified Microsoft Technology Associates. Welcome, Mr. Vivek, for the webinar. Over to you for the webinar.
Thank you, ma'am, for the introduction. I'm really honored to be part of this webinar series. And without wasting time, let's just straight away dive into the content of the webinar. I will just share a PPT, and you can give me a confirmation in chat whether it is visible or not.
Yes, the screen sharing is visible.
So whenever we hear the word cloud, we just simplify it as it's just someone else's computer where we run our programs, or where we lease their infrastructure for our work. But cloud is a very major giant. Without cloud today, most of today uh, today the startup culture is also powered by cloud, because if you imagine 10 to 15 years ago, when cloud wasn't such a uh, such a everyday technology in such at such a good level, uh, before deploying any server, you need to buy a warehouse, then you need to rack and stack your servers there, you need to rack and stack your databases there, then you need to maintain the complete security of those data centers, you need to maintain the power of those data centers, you need to maintain the power backup and data backup, and it was quite a tedious job to run such a giant infrastructure completely on its own for a new company or a new business. That's where cloud came handy. It made that thing simpler. So let's begin with the cloud itself. The cloud can be broadly referred to as someone else's computer, but more realistically, it's collection of services which create a platform. These services might relate to virtual server data storage, networking, machine learning, security, analysis. All these services come very handy with cloud, and every service has a specific role with only one aim to make your organization powerful and your organizing life hectic free. Instead of you having to do all yourself, like as I told, that server room and then making those, building those huge servers and then maintaining everything, you can just pick someone else server, pay them the rent of the server, and the server can be anywhere in the world, and you can also use it from anywhere in the world remotely. You can fine tune them to do what you can fine tune them whatever your requirements are. You can pay less actually than normally hosting it by yourself. So before cloud, this were the traditional data centers. Here you need to make a single server for every service or every web application that you were providing. Then came virtualized data centers. Here there was no need to maintain a single hardware for a single application. But rather than that, you could just build a huge hardware, provide a hypervisor or virtualization layer, and above that layer you could host different applications that would share this infrastructure among themselves. You can divide this infrastructure, divide the usage among these applications using this hypervisor. So think like so just to show you what advantage cloud computing brings to the table, and how it's different than traditional. The biggest advantage of cloud computing is that you pay for what you use. So even if I have some service that I have posted on, let's just say Amazon EC2, or I have some data and analytical requirement with a awful lot of compute power and also a lot of services, especially if you are scaling out horizontally. So if you were to do this yourself, you would have to go out there, buy this server, then build them, power them, manage the in-out security, or you would buy it from HP or Dell. You are in three, when you buy this from market, or let's just say from HP or Dell, any server provider, you are in minimum 3 to 5 years contract. So it's very expensive. Great thing is where that is why pay as you go is a great thing. If you are using those servers for a minute, you pay by minute. In fact, now Amazon has bought many services to per second billing. So even if you are not using that service for a minute or less than a minute, you will pay for seconds also. Depending on service, you can go in. So now you have calculated all this infrastructure and you have locked them in, you have locked with HP or Dell for 3 to 4 5 years contract. The future, so now in future, if your service gives some issues or your service need to be scaled up, or aren't as many users as you thought before hiring this, before building this servers are using this service, so you are in a really uncomfortable stage where you have invested a lot of money into the server and your server are not even used, and still you have to pay those 3 to 5 years lease or the rental expenses to this uh, server providers. That's where cloud computing came. So even if I am not using it, I can just shut down my instance or shut down my server, and I'm saving that cost. In fact, when I'm not in a production or I'm just testing my application, so I can just switch on my server for the time of testing. And again, at night, when the server is not in use and no one is working on the application, you can just turn off the server, and you can easily save cost there also. So the basically cloud computing is about renting the resource versus purchasing the hardware. But you really need to make sure that you are running your applications, you are storing your databases on someone else's data center. Here you are not the owner of the hardware. Uh, so before hosting any application to cloud, this one thing you should consider. Uh, Also, cloud computing works on a shared responsibility model. So where the responsibility of hardware, physical hardware and facility necessaries like powering the facility, securing the data center is the provider's work, and whatever goes on to the hardware level, like the applications, the systems, the database structure, that's responsibility of customer. So in simple language, you can explain this way. When you rent a flat, so basically the responsibility of the main gate, responsibility of the building gate is of the uh, builder, right? He provides fence, he provides the guard security, he provides the fence, he provides the roads, he provides the uh, let's just say a swipe card to the lifts. In many hotels it is, but the basic responsibility, that is uh, your house responsibility, that who will enter into your house, who will have the key of your house, that's your responsibility. And cloud provider, so this is the shared responsibility model. And now these are some core cloud services. So basically these are the 5 core cloud services. So compute, when compute can be easily said, easily we can just to understand compute, the easy word is compute means server. So when you what will be the processor of your servers, how many cores of processor you need, do you need a GPU, do you need a CPU, how much RAM do you need, that's all come under compute. Then comes storage. So what kind of storage you need, how much GB of SSD you need, what will be the storage type, whether it will be a DBMS storage or S3 storage. So S3 is basically the object storage in Amazon, where you can store your photos or video content, that content, also archive your data. So this is the storage service. Then it's the networking service. Since cloud works on internet, and if AWS and Microsoft, all these are public clouds, networking is really important. You need to connect, you need to pinpoint each and every port to exact location where you want that port to give ingress traffics and outgress traffics, or in traffic or out traffic. Also, networking security is also customer's responsibility. Which firewall service is provided by the vendor, Amazon or Azure, any of the cloud provider, but exact rules of those firewall will be managed by user or customer. Then there is an application service. So application service means it's like elastic bin stocks, where or basic application service, can we can straight away say uh, they have all the hardware underneath ready. You just need your code, go on this application service and deploy your code. These are the application service. The major example of application service can be a Q&A maker, Azure Q&A maker. There they set everything. You just need to go there, upload your Excel file, upload your PDF file, and you just are ready with your Q&A data set. Then it's the analytics service. So analytics service is basically the log service. Every time you build some server, you build some database, you connect those servers to database, there are log that are made. The which IP addresses were permitted to the storage, which IP addresses were permitted to the servers. All these logs are then analyzed in case of a threat or in case of an attack, that which IP address or which suspicious IP address we need to filter. So these are also analytics service that are provided. The second analytics service is a big data service. So it can be then it can be big data services where you have tons of data, you have terabytes of data, and you need to analyze those data. So those services are also provided by cloud service providers, and it's a core service. So this is just a joke where that goes around in my company also. Many people have got this t-shirts, and looks really cool when you are working in a cloud company, or you are just pursuing cloud, or you have an interest for clouds, that uh, there is no cloud, it's just someone else's computer. Or now let's just come to the important part, the elasticity. This is a major benefit that cloud computing brings to table. As your workload changes, resource can changes to compensate. So in the left side diagram, you can see this dark black line, the horizontal line, that's the limit your on-premise server or your IT servers are you have set. So let's just consider you have got here a 4-core CPU and a 16 GB of RAM and a 128 GB of SSD. So when your application is running, uh, your application usage is set. Like suppose 10,000 users can use it at max. So even if any day 10,001 users or 10,000 or 1100 users log in, so you are using the resources just really below to your limit what your service can handle, or sometimes the limit of users can go above to the limit of users your server can handle. So this can be a really bad stage for any uh, infrastructure. Here the server may get slow or may get crash. And here, so cloud computing brings a elastic scaling feature or a elastic scaling advantage. Since you are not committed to any fixed hardware requirements, you can use some auto scaling services, or you can manually scale up your system whenever you need. There might be a user increase on your application. Let's just consider Flipkart Big Billion Sale. So during Big Billion Sale or flash sales, many users log in for those 1 or 2 minutes because because of the kind of deals they provide. So just for that 2 to 3 minutes, Flipkart wouldn't be maintaining such a huge infrastructure annually, right? So they just use auto scaling features on cloud. So whenever they put the sale live, before that, they just scale up their systems to certain users what they expect. And then whenever the user decreases after the sale or after the Black Friday sale, or let's just say at night, they just scale down the systems. So again, you don't have to pay the extra cost for under using your services, but you have to under using your services, so that this can save systems from crash and also save enterprise a lot of money. So also a big advantage of for elasticity and upscaling is scalability. You can increase or decrease based on your workload demand. As we discussed in previous slide, here we were decreasing our resources at night, or let's just say when it's not a big billion day sell, and when it's big billion day sell, or the increase or any new smartphone has launched and it's a flash sale, you can scale up your systems. So there are two type of scaling. First is a vertical scaling. So this is a scaling up. Uh, you just add additional resources to your already running servers. So if I'm running a server that has 4 cores and 16 GB of RAM, and now when I want to vertically scale it, I will just increase cores or increase the RAM. That is also feature that is also what cloud provides. You can easily vertically scale or just scale up your system. The second scaling is horizontal scaling. So this is basically um, scaling out your system. So if I'm having one server that is running 16 GB of RAM and 4 core of CPU, so instead of just increasing the core CPU or RAM, I can just increase one more server with same specifications or different specifications. So this is called scaling out. This can be easily understood by this GIF. So vertical scaling is basically increasing the size of your current system, and horizontal scaling is increasing the uh, number of systems that are on your ongoing infrastructure. So here you increase the number of server, and here you increase the power of server. Then it's a cloud service model. So this is term that is widely used in industry, or whenever you hear a word cloud, or in web, whenever you hear a web application, there are acronyms like PaaS services, SaaS services. Like, so what are actually these PaaS services, the platform as a services, the software as a services? So before just jumping into the technical definitions of this, it will be really handy and really easy to understand what these services are. Instead of considering platform as a services or cloud as a services, we will consider a, a scenario of pizza as a services. So, uh, so basically a traditional or on-premise. So the first table shows the premises, the traditional or on-premise data center. This is like making pizza at home or making a server at home. Here, everything is your responsibility from dining table to soda, the electricity of oven, the gas of oven, the fire for the oven, pizza dough, tomato sauce, toppings, and cheese. Everything is responsibility of customer. Now let's just consider infrastructure as a services. So this can be take and bake, or let's just say the frozen pizza, the Amul frozen pizza. So here what Amul is responsible for is Amul is responsible for cheese, dough, sauce, and toppings. And what as a customer is your responsibility to bring that frozen pizza home. You are responsible for the electricity, the gas, the oven, and soda and dining table to eat that pizza or to consume that service. Then it's platform as a service. So platform as a service is like pizza delivery or Domino's, where Domino's is responsible for completely making pizza. Toppings is their responsibility, cheese, oven, in fact, electricity and gas is also their responsibility. They will just deliver to you. So as a consumer, your only responsibility is to arrange soda and dining table to eat that pizza. So this is platform as a service. Then it's software as a service. So this is just an example of dine out, where everything is responsibility of the vendor or the business person. As a consumer or as a customer, you will just go there, use that service, use that pizza, and then pay the bill and come out of there. So I will just give you, we will just take us a 1 minute time. You can just go through the services, because this will be really helpful to understand what actually in technical terms this infrastructure as a service, platform as a service, and software as a service means. So, here, whatever is green is responsibility of the business person or the vendor, and whatever is blue is responsibility of customer. So now this is the technical. In cloud terms, what infrastructure as a services is, what platform as a services is, and what software as a services is. So traditional IT or in traditional data centers or on-premise data centers, you are responsible for everything. The web application that you are running, the code that you are running, the database for that code, the runtime, the middleware, the antivirus, the operating system that will be running on your server, the virtualization layer, the server, the storage, networking. Uh, in fact, you are responsible who will go into that server, who will go out from that server. You will have to maintain the physical security of data center also. Everything is responsibility of business, and that's why it's really complicated to manage, because business have to invest lot of strength and lot of time and lot of money into managing these services, managing the engineers, managing the securities, and managing the system that is required for that security. Then this is the infrastructure as a service. So the example of infrastructure as a service are the major cloud providers. That can be Azure, that can be AWS, that can be GCP, that can be DigitalOcean. So these are all the major infrastructure as a service providers. So so relate the IT service model infrastructure. So infrastructure as a service is where you have a hypervisor and the hypervisor, you can provide virtual machine where you can actually rent this virtual machines to host your physical application itself. Now platform as a service. So platform as a service is basically something like elastic beanstalk that AWS provide, or web application services that Azure provides, or let's just say a real-time database service that uh, GCP provides. So this is where you don't have to necessarily know what resource you need, but you just go there with your code and you will then use their platform as a service to go in and provision those resources for you. So Elastic Beanstalk will provision you with Elastic Load Balancer, the EC2 instances, the databases. The real-time database system from GCP will we make sure that the underline what kind of database storage you are using, the firewall what for those storage, the inbound rule for those storage, the software upgradation for those storage. You are just responsible for the database, the core database, the core code that you will be deploying there. At beginning, this platform as a services was really a strength for Azure. But since AWS launched Elastic Beanstalks, this was a unique selling point for Amazon, for Azure, and that has been just distributed among now two service providers. Also, Google has also the similar service Google has have is a Google App Engine, where you just need to go there and deploy your application. The computing, the database beneath that application is everything managed by Google. Now, software as a service. So software as a service is easiest thing to understand. Let's just consider uh, if you just think about something like Gmail. With Gmail, all you worry actually is about the software. You don't actually worry about is the software. You worry about your inbox, you worry about your spam filter, that sort of things. You are not worried about understanding servers. You have nothing to do what is beneath that application, whether Google is what kind of load balancer Google is using, what kind of scalability Google is using. You just need to use what the software Google is providing. So one of the major example of software as a services is the G Suite, the G Suite. So Google Slides, Gmail, Skype, and also one of the major example of software as a service is Salesforce. Now, since cloud is about renting rather than building the infrastructure, cloud economics and understanding the pricing in cloud is really important, because you don't pay anything upfront. You pay for what you use. So if you are using service more than your requirement, or you have not configured the services well, or you are not using proper services with proper inbound rules and proper outbound rules, then you may end up getting a very high bill for Amazon or any provider, because uploading anything to cloud is free, but hosting anything on cloud and using anything from cloud or transferring anything within the cloud or outside the cloud cost you money. Usually that charges is per GB basis. So cloud economics and understanding cloud pricing is really important. So basically economics of scale is the first factor. So economics of scale is availability to do things more effectively at lower cost per unit when you operate at a large scale. So what benefit the cloud brings? So when for the on-premise system or traditional system, you need to buy the hardware. So you won't buy like you won't buy hardware in a wholesale amount, right? But when Amazon buys the hardware, it buys in such a big quantity that uh, that those buying results in really discounted rate for Amazon. So it's just like when you buy a single pencil that will cost you 3 rupees, but when you buy a box of 10 pencils that will cost you 20 rupees. So eventually you end up saving 1 rupees on a single pencil. So that's 10 rupees on complete box. Same goes with cloud. When you buy a hardware versus when Amazon buys a hardware, or Azure buys a hardware. Also, there are very local government deals that are provided, because whenever they build data centers, or whenever they build any offices, whenever offices in any state or any nation, any country, they create lot of jobs. They create thousands of jobs. So government also provide them some tax benefits, some electricity benefits, some discounts on lands. So this is uh, also some insurance. So this results in really low cost. This results in saving money for Amazon, which actually gets reflected to its customer also, or any cloud provider, and the customer also get benefit of this savings. Also data center efficiency. So even if I have to run 2 racks or 3 racks, I have to still maintain the security. I have to still maintain the uh, backup backup electricity. I have to still maintain the backup internet, even if for one data center, and even if for when I'm hosting 10 racks, these requirements are just consistent. So when Amazon makes 10 racks, it really makes this management cost or this maintenance cost really reduced for on an average for every rack. And basically cloud providers pass this economics of scale to customer also. So there are capex versus opex. So capex expenditure is basically when you spend on and infrastructure and you have to pay complete upfront cost. So and now when I'm paying crores of rupees for a data center, it will take time to write off those cost, right? So this includes the typical server cost, the hardware cost, the backup and archive cost. Also, I have to make a disaster recovery data center also in case of any disaster on my uh, primary data center. Then it's the operational cost. So what operational cost is? There is no operational cost when you buy server from Amazon, when you host your application on Amazon, or you host your application on Azure. You don't pay anything upfront. You pay for what you consume. So even if I'm not consuming a thing of, or I have just shut down an instance, I am really saving a big money on that there. So so there are some benefits of apex and there capex, and there are some benefits of opex. So in capex, you actually can predict how much it will cost because you receive quotations for these big service providers, big hardware providers. And if you are consuming your complete infrastructure and you have uh, exact amount of user to that service, you can save the capital expenditure on that service. Then the operational cost. So here you can just try a system. So I can try a CPU. Let's just say I can try a T2 micro CPU of Amazon. And if I feel like my application is not giving me performance on that CPU, I can just upgrade that CPU. This is also low initial cost, as I told earlier, right? When you are just in a testing or when you haven't released your application in production, you can just switch off when your company is not working or your team is not working on to this, and you can uh, save a cost there. So cloud deployment model. So there are basically three types of clouds. This can be just a cloud. So there is a public cloud. So this is just one of the most common deployment models. So Azure, Amazon, GCP, these are all public cloud. Anyone can go there and use their cloud. Just he need to put his credit card number. He need to make an account there, and he can use this public cloud. There is no need that he should be a registered company. If, in fact, we can go there and create our own account and just uh, try to host a web services or a WordPress application. So the advantages of the public cloud are they are highly scalable. They are pay as you go pricing. You are not responsible for maintaining any update or any hardware, and the cloud providers say that minimal technical knowledge is required. So here minimal is you must know the basic terms like what are the networking protocols, and what are the basics of servers, and what are the basics of ingress and out, basics of type of databases. Disadvantage is there can be some security issues. Many government doesn't allow hosting their data on public cloud, and you don't own a hardware. So if you have some bank application that is on a drive, now your bank policy says that when you just close your old service and upgrade to a new database, you must destroy your database uh, physically. So this cannot happen because you don't own the hardware. And if just like this bank have a unique business requirement, this can not be you cannot have something unique business requirements for your public cloud. So private cloud is basically, it completely looks like a public cloud, but only your company or your employees can use this cloud. So this isn't something like traditional where you make single server for a single application. No, you just make a complete hardware infrastructure. About that, you host your hypervisor and then you host services onto that. So this provides you complete control over all resources from hardware to software. This also provides you complete security control, who can use it and who cannot use it. And also there are some business requirements that public cloud cannot meet, which this private cloud can meet. So disadvantages are last upfront cost. There is really high skill required because you need to know everything from how you make a connection, how you put a firewall, how you attach and gateways, how you make some jump servers, and also you have to manage the data center. Then it's hybrid cloud. So this is basically you use something from public cloud and you use some resources from your private cloud. So this provide you flexibility. You get some legacy systems like network firewalls that you can attach and attach which you cannot attach on public cloud. Continue with your own equipment. So even if you have some equipments in your private cloud, you can use this equipments. But since there are two clouds involved, this is a really complicated architecture to work on. Now, what is AWS? So this is quite important. So AWS is world's, so the cloud has, so AWS is world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured service from data centers globally, million of customer use. So AWS might be one of the giant in this field. They offer over 175 fully featured service and around 250 basic services or features. Uh, Also, AWS are really big giant and they are really aggressive in market. They own around 40% of the market share currently in cloud. The second is Azure that own around 19 to 20%, and the third is Google that's own around 10%, and rest of all cloud providers own around 20 to 30% of market share. The biggest thing AWS has is it's the first mover advantage. AWS bought its first service EC2 in 2006 to the market, and nearly Azure bought its EC2 offering or virtual machine offering to market around time of 2012 and 13. So they are actually 5 to 6 years ahead ahead in bringing their first services to market in compared to other the second cloud provider, that is Azure. Uh, Now, since AWS is a global infrastructure, there are around 250 services that are deployed in various regions. Some services may be available in a single region, and some services are available on a global scale. So so what basically region and availability zones are, because this is really important to understand what actually this global infrastructure of AWS looks like. So basically, before deploying those data centers, AWS have four major, let's just say, just like world is divided into continents, the AWS is divided their data center region in four regions. So first is North America region, then it's South America region, Europe and Middle East region, Asia Pacific region. So in North America region, actually you can go on this about AWS global infrastructure and check what are the regions that are provided. So whatever where you see this golden circle, those are the regions, and where you see blue circles, so these are edge locations. So the region can be a vast area where their data centers are hosted. So in one region, there isn't a single data center hosted. There are multiple availability zones, availability zones made. So one region is divided into multiple availability zone, and this multiple availability zones are then divided into multiple data centers. And also for security reasons, AWS doesn't specify how much exactly data centers they have deployed in each availability zones. Also, they just give a code to the availability zone. They don't explain you what the availability zone is and what are the what are the name of those availability zones for security regions. So here you can see the East US OEO has around 3 availability zones, which was launched in 2016. US East North Virginia region has 6 availability zones. So North Virginia has the highest number of availability zones because it's one of the most important regions for AWS. Anything new offering AWS brings, it's first brought to this region and then to other regions. You come to Middle East Europe, you can see these are uh, the regions and these are the availability zones. In Asia Pacific, if you see, in India, they have one region. In Asia Pacific region, they have one availability, one region in Mumbai. That is Asia Pacific Mumbai region. There are 3 availability zones. That this was launched in 2016. So the basic rule is a single region cannot have single availability zone. There will be minimum of 2 availability zones. So if one availability zones uh, get some issues, or there any disaster happen on one availability zones, there is another availability zones and stand-up availability zones that can then fluctuate the traffic, or you can use those availability zone. And it is highly recommend when you are launching servers, you launch your servers in multiple availability zones in multiple region, just in case of disaster recovery. So the third physical location is the edge location. So edge location is basically uh, AWS makes a, edge location where they just cache the memory, they deploy their CDN services. So it's really easy for a customer to connect to this edge location, use that service rather than straight away connecting to the region. This edge locations are connected to regions with a high private network, and private networks that doesn't break or doesn't decrease bandwidth with time. Next is a 10,000 foot overview of what actually the AWS console looks like. So when you log into the AWS console, so this is how the AWS console looks. You can see here the name and what the account number. Then it's here you can select region. So let's just go to Northern Virginia region, because that's the basic and that's the core region of AWS. From here, you can just contact support center and get any help if you need. They provide help in respect to pricing. They provide help in respect to architecture. They provide the technical help also. Uh, you click on uh, so this is the first menu bar, and now so here it is the ever changing experience of AWS console. Actually, AWS deploys so many new services every year that that console just keeps on changing. So it's better to straight away jump and click here, where you can see the complete list of all the services that AWS has offered. So here comes a really bunch of columns, the services that AWS offer. We have we have 4 columns in the view. It starts with the compute. The compute, and compute refers to services which are related to running application or processing things with computing power. With AWS, this can refer to virtual services and serverless computing. So here it is a EC2 service. So basically EC2 is the virtual server in the cloud. When you go to EC2, you can see what's the one line description of those services. This light cell is the light light cell is really handy services where AWS manages all the Binet infrastructure, and you can just straight away launch your WordPress application or application onto light cell, easily connected to the DNS server, and you can have your website traffic to your uh, WordPress application hosted here. Uh, then this is a EC2 image builder. So any if you host a single service, if you host a application in your EC2, you can go to this image builder, build an image of those application, and the next time you deploy a new service, you can straight away run this image, and your application will be running on that instance by default. So this will just copy the exact hardening softwares that are on this server, or the application that are this server, and replicate it on another structure. Now this is a storage service. So storage service consists of S3, and S3 is one of the first offering that AWS has bought. S3 is basically like a Dropbox service, or in simple terms, it's an object service. Here you can save videos, you can save images. There is no fixed format, or the database need to be in standard format to save to the S3. Then it's elastic file storage services. This basically, you can store your files, you can store your data files into this. Then comes the S3 Glacier. So S3 Glacier is basically when you have some archive files that you don't need to be on S3 and pay a really hefty amount for S3. You can just opt for S3 Glacier. This is a slightly uh, inexpensive services where you can save your archive that you don't need to use frequently. Then these are the databases services, and these are quite self-explanatory. Migration and transfer services, these are when you want to migrate from your on-premises to AWS. These are really handy services. Network and content delivery. So VPS is basically the spine of AWS. This is virtual private cloud. You can actually make your virtual cloud on AWS, and then you control what the ingress traffic to that virtual cloud will be and what the outgress traffic to that virtual cloud will be. Uh, CloudFront is basically AWS CDN service. Uh, Route 53 is the DNS service. Then there are this developers tools that AWS provide when you need to test or deploy any application. Then there's robotics service. There is only one robotics service offered from AWS till today. Then there are customer enablement. This is basically support and documentation customer needs. Then for all the blockchain or cryptocurrency enthusiasts, AWS also provide a blockchain service. Then the major services management and governance. So here you can just manage your logs for AWS, the licenses for your application, the licenses of your softwares and other services. Then this is a media services. So AWS offers a very bunch of media services that has made it quite a huge platform for all the major OTT platforms. Now the machine learning and data science are one of the biggest, data analytics are one of the biggest industry in IT today. And this is what AWS has to offer in this two fields. Then security in cloud is really important since you are on public cloud, and AWS provide a bunch of services. IAM is basically here you can create user who can use your services, who cannot use your services. You can attach policy to that user. Then it's Amazon Messi is a machine learning based uh, service that scans your databases, and if any critical information is there like credit card details or any transaction details, that Amazon Messi that is unencrypted, that Amazon Messi gives a notification. Then WAF and Shield is basically the web application firewall services that AWS provides. Uh, Front end web. So AWS provide this front end services for your when you want to make front end for your application also. There are AR and VR services that are offered by AWS if you have any app that runs virtual reality basics also. Uh, app, and app integrations are basically the app flow log. You want to make pipelines for your production app and other things, you can manage it from here. AWS cost management is really important because everything is on rent. So you need to know exact what your budget for that application will be and what cost actually is under that services. Uh, Rest is the business application. The CHIM is AWS, just a Zoom type application that AWS provides for businesses, Alexa for businesses. Now, Internet of Things is also on AWS. Here you can use IoT core to attach your multiple devices on AWS, and you can then use it. Game development is also a major offering from AWS. Here you can store your, here you can host your game applications. And the end is the container service. Here you can manage your containers, your Kubernetes and OpenShifts for AWS. Uh, uh, AWS is such a giant, we cannot complete or just even an introduction cannot be given in 1 hour. So this was just a 10,000 foot overview of what exactly AWS is, what exactly the cloud is, and how the AWS console looks. So if you want to just learn AWS, the best thing is to go out there, make a AWS free trial account, and free trial account that is valid for a year and gets your hand dirty. Uh, so whoever want to just train, AWS also has a portal for AWS training where you can actually go and just train yourself depending upon what certification you want to take. So basically the first certification is AWS Cloud Practitioner. This is just a fundamental certificate that you just need to know what the basics of services are and what basics of AWS console is. Then you can choose whether you want to be an architect, that is whether you want to maintain the big systems, or you just want to be in developer side or operational sides. This is the path how you need to study. Then there are the specialty services that AWS offers. So this is the specialty in a certain kind of system. So like advanced specialty in networking, specialty in data analytics, specialty in security. I actually appeared this security exam 2 weeks ago, and I actually failed that exam with 1 or 2 questions. Just I scored 710 marks, and 750 was passing. And this portal, the AWS fundamental or the AWS certification portal, was quite handy. So that's it. You can ask questions in chat.
Thank you, Mr. Vivek, for such an informative session. Now I'd like to ask questions which I've received in the comment section. The first question is from Sujata O, and the question is, how cloud in AWS services will be useful in a DevOps culture?
So when you see what DevOps services AWS provides, so AWS provides a lot of DevOps services and integrate with lot of DevOps services. That can be Git, that can be your pipelines. You can maintain, you can just deploy your application in a single pipeline, and your infrastructure team then will take care what the infrastructure is required for this uh, for those applications. So this really sort things out for what exactly workload what exactly role the engineer has.
Okay. Next question is from the AN Zadav, and the question is, can we have an assured service that our data will be only stored on a servers only in India?
Yes, your data, as I said, that there are various region, and when we were on console, I will just go back to the console and share the screen. So when you go here, you can just select here the region where you want your service to be hosted. So when you select Asia Pacific Mumbai, now you are in Asia Pacific region, Mumbai region, and now you can just opt for S3 storage services and build a bucket and store your data in Mumbai region.
Okay, let me ask a last question. Which certification will be useful to work in the field of cloud computing?
There isn't a one certificate. So you first need to select, right, what your interest is or which cloud service you want to study. I myself started my internship in Azure, and then I slightly moved to AWS because my company had more projects in AWS and not in Azure. So it isn't, it's really easy to shift between the clouds because the core service offering of both the clouds are same, just the name are different. So even, so if you opt that you want to learn Azure, the first certification you should go for Azure is Azure AZ 900. And if you opt for AWS cloud, the first certificate you should take is cloud practitioner. You can just go onto aws.amazon.com/certifications, and they have a really good explanation of what your certification path or what your learning path should be.
Okay. Now the Q&A session ends here. Now I'll hand over to Ms. Jyoti Joshi ma'am for further proceeding. Thank you.
Thank you, Sachin, for this previous session. And Vivek, it was really an awesome session. Uh, we had a lot of learning happening in this session. Very informative session. Thanks a lot, Vivek, for this webinar.
Thank you, ma'am.
Yeah.
It's my honor to be on this series. Thank you.
Thank you, Vivek. Yeah.
Thank you,
Now,
everyone, for coming to the session.
yes. Thank you, Vivek. It's now time to conclude today's webinar, and I'm Ms. Jyoti Joshi on behalf of Information Technology Department of Dr. D.Y. Patil Group, Steam to University, Ramrao Adik Institute of Technology, would like to conclude it with a formal vote of thanks to our beloved founder, Dr. D.Y. Patil sir, for being the guardian angel throughout. My heartfelt gratitude to our Chancellor, Dr. Vijay Patil sir, and trustee Ms. Shivani Patil ma'am for giving us such unconditional support throughout. I would like to thank Principal Sir Dr. M.D. Patil Sir for his motivation for conducting such knowledge sharing webinars. My deepest thank you to our HOD Sir, Information Technology Department, Dr. Ashish Jadhav Sir, for guiding us throughout. Now I would like to thank our live media team for being an active support throughout this webinar series. Hope to see you all for next webinar. Thank you all. Stay home, stay safe, and keep learning. This webinar ends here. Thank you.